All right, everybody, it's Great Church. Every single week later, easier, power, what's Great Church?
Okay, so we just say speed one. So we're doing this triple output RG matrix active bonnet, which I designed and I was just showing it off. It looks like this, and it has a 3 to 5 volt level shifters on the back as output to drive the Hub 75 matrices. They want 5 volt power, and they really want 5 volt logic too. Even though they don't need to, and some work without it, I found that 5 volt is the best way to go. So this does active level shifting. And to do that, we need to shift a lot of pins from 3 volts to output. And it turns out to be like 8, 16, 24, 25, 26, a lot. And I want to use an 8-pin level shifter, and I want it to be able to handle 10 megahertz or higher. That's important. Like I don't want a slow chip. And the most important thing is it takes 3 volt logic in, but outputs 5 volts. So you power it from 5 volts. That's how you normally do this. Sometimes you have 2 outputs selection, but basically just make sure that it can handle 3 volts input safely, output it to a clean 5 volts, and do it quickly and be small. I want it to be like, HT-SOP or H-SOP. Not SOIC and definitely not DIP, right? I want it surface mount, small, compact, easy for me to place, and inexpensive because I need 4 of these, right? I need 4 of them. And if they're like 50 cents a piece, like suddenly I'm paying $2 for level shifting. I don't want to do that. I want to pay like less than $1 for all of them, less than 50 cents for all of them. So let's go to DigiKey and see what we got. Okay, so we want, these are actually called buffers. So there's non-inverting and inverting buffers, but they're all kind of in that same buffer, driver, receiver category, things that take like one signal and convert them to another one. So as usual, we're going to look for active only. And let's do stuff that's like normally stocking. And we're going to exclude marketplace products just to keep it a little bit more organized. Marketplace usually duplicates of stuff. And this is a common item. I'm expecting DigiKey to stock this. Now, there's one thing that's a little bit tricky here, which is number of elements. Now, remember, I want as many as possible. And in general, logic either comes in 1, 2, 4, or 8. You can do others, but it's usually like the cost gets a little bit expensive. So I want 1 and 8 here, and I want 1 and 8 here. Why? Because it could, the way that they might consider it like 1 bus times 8 pins, or they might say like, well, it's 8 pins and like each one has an output enable or something. I don't know. So I just want to make sure that there's like 8-ish of 8-ish. Okay, I still got these 1s. Unfortunately, there's no way to say like, well, I only want one or the other. But if I look at the ones that do have like the more pins, and that's another thing is I can filter out all the SOT 23s, because anything that's less than, I know anything less than 16 pins isn't going to be a valid chip. So I'm going to pick only the 20 because I need at least 8 in and 8 out, and then power and ground. Okay, so like at least 18 pins, so 20 to 24 pins. These will never have enough pins, and that really helps me filter out all those individual items. Now we're getting to, these are looking good. Lots of pins, and they're like non-inverting, inverting. So let's look at those inverting and non-inverting. So there might be situations where you want to invert the signal as you buffer it. We don't want to, so we're going to pick non-inverting. Transceivers go both direction, which I don't care about. That's not unusual, but like I can always just set the direction. I only want it to be outputs, not a big deal. And then I don't want open collect or open drain. I need it to be push-pull. Tri-state's fine. There's an output enable. That's okay. And then, okay, so now we're looking pretty good. So now we have to look at the voltage supply. Now remember, I want a level shift from 3 volts up to 5, which means that I need to have the power supply be at least 5 volts. And so I'm going to go through and like I'm holding control, and I'm picking only the ones that cover 5 volts. So like I'm skipping the 1.6 to 3.6 because that's not going to be able to give me a 5 volt signal. Okay, cool. So this is looking pretty good. Next up, I could filter out and say I don't want SOPs or DIPs. I only want surface mount. That gets rid of another 50. One thing about looking for a logic level is you're going to see that there is a lot of options, that's kind of generic. So you'll see many companies come up with very similar chips. Another thing is I don't want SOICs because they're going to be way too big. So let me just pick off, I'm going to just skip, I'll take the QFNs, but I'm going to skip the SOICs. That gives me, a slightly smaller number. That way I don't accidentally get one that's bigger. Another thing that, if you guys saw on the package and case is that SOPs, TSOPs come in different widths, and this really bites me. Sometimes you have to really watch out. Some are skinnier and wider. You can have a footprint that supports both. You just have to have really long little tails, pads on your footprint, but just watch out because I have many times I remember once the extra wider ones instead of the narrow ones. And then from then on, I just I had to redesign the board or maybe I returned them. But from then on, I just used the footprint that was the wide one and had support for you could put the narrow ones down and it would just be they'd be kind of sitting there floating in this wide pad. Okay, so now we've got lots of options. So the only thing is that none of them really tell you are they level shifty. Now, if you knew your 74HC logic type, you could pick those out. But instead, what I'm going to do is, pricing was important. So I'm going to just say, because I need 4 on each board, and I make about 250 pieces on my first run. So let's just make sure that, I'll start at the top and I'll see which ones are available. And different series will tell me VHC or VHCT. So let's look at, let's say I don't know each one. But you do want to read the description, and they'll tell you some things. And one thing that was interesting is they said here, they're no, you can see this came later because I guess people used it the wrong way. They said there's a diode between the bus and VCC terminals. And so you can't use this for 5-volt and 3-volt systems. You can't mix and match them. Could you make it work? I don't know, maybe, but I'm going to just say hey, skip it because I don't want to, if it's giving me a warning, it's going to be more work than it's worth. And then, so we can go to the next one, AHCT. And this one is a transceiver, synchronous two-way communication, runs from 4 to 5 volts. And then, they show you the direction. They go each way. And there's output enable. It has a kind of a standard pinout, comes in a lot of different packages. And then, so we want to make sure that the input voltage range is compatible with 3.3 volt logic. So we go down to the recommended operating conditions, and they're look, you have to power from 5 volts, and that's cool, no problem. The input high voltage is 2, which is good, because if it said input high voltage is 3.5, which sometimes it does, that's not necessarily going to work with 3.3 volt logic. It might not work because they're saying, look, your input voltage has to be at least 3.5, but your 3.3 volt logic, sometimes the logic might trigger a little earlier, but for the most part, you need to make sure that the signal coming in is higher on the high level than the high level input and lower than the low voltage. So this one will work because the input is 3.3 volts higher than 2, and the low input is going to be 0. It's lower than 0.8. And then you could have up to 5.5, but so this actually can, this can shift from, this won't work with 1.8 volt logic, but it will work for 3.3. It will work for 3 logic and maybe 2.8 volt logic too. And then the last thing we want to just check real fast is, is the speed. Now, sometimes this doesn't really matter, but I do know that I'm going to have at least 10 megahertz signals coming through. So let's check, I'm going to assume that we're running it your standard, non-industrial, you're up to 85 degrees C. Temperature, let's say, it's nice and warm. I don't care about OE because the output enable is always going to be on. I care about signal, how long does it take to move the signal from one side to the other? And there's different capacitances. Let's say we have high capacitances. We have this long cable. So at worst, it's going to be, 11 nanoseconds. It's 10 nanoseconds. Let's say 10 nanoseconds. So we say, 10 times, let's just do the nanoseconds. So it's 1 divided by 2. 1, 2, 3, 1, 2, 3, 1, 2, 3. That's a nanosecond times 10 nanoseconds. Invert it, 100 megahertz. So you know, divide by 2 because you have to go up and down. So 50 megahertz is, you know, the, what's it called? The transport. And hold on, there's a word for it. Propagation, right? The P is propagation from low to high or high to low. So way more than the 10 megahertz that I need. So I know I'm good to go. So this chip will work just fine. It's like the lowest cost one, but you know, if you're willing to pay a couple more cents, some of these have tariffs, just watch out. That could be 10%. So that can increase your cost, but this one is tariff free. So you can pick this one. But here's the good news. Now that you've checked the data sheet, check that data sheet for other alternatives just in case. But 99.9% of the time, if one of these A74AHCT 245s will work, the entire family will work because all of them have the same specifications. And then the SN is just like TI's prefix, and the DGSR is the packaging suffix. So the core name for that logic is the 74HC 245. This will work great as an 8-bit logic level shifter from 3 to 5 volts.
All right, and that is the research.
Where in the world